821. How can I write the equation? In this lesson, you will continue your work with exponential functions as you develop a new method to write linear and exponential equations given 2 points. And I'm not sure this will really be a new method. I think we've kind of delved into this stuff already a little bit, but just in case. So how can finding linear equations help you form strategies for finding exponential equations? Parts A and B below will help you answer that question. So in the equation y equals mx plus b, which letters represent variables? That would be x and y are variables. And which represent parameters. M and B represent parameters. Parameters are essentially just variables that have like a set meaning. So if I say y equals 3x plus 5, I know that the slope is 3 and the y-intercept is 5, and that will always be the case for this line, whereas the x and y can change. Now, obviously, parameters can change as well, but what happens is when you change the parameters, you've changed the line. So that's kind of the difference between the two. I hope that's clear. Probably clear as mud. Anyways, what is the equation of a line with the slope of 3 that passes through 0.519? Well, I know that my y is 19. I know that my m is 3. I know that my x is 5. And I know that I don't know my y-intercept. So, pretty simple that we can go ahead and do that. Now, obviously, b would equal 4. And we would get the equation y equals 5x. I'm sorry, y equals 3x, my mistake, plus 4. And that makes sense because if I plug 5 in, I get 15 plus 4 is 19. So that would be my equation. It says take note of that method because we're going to see it again. So consider, can you use similar ideas to find an exponential equation? So in the equation y equals a times b to the x, which letters represent variables? Well, the x and the y do. Which represent parameters? The a and the b. The a is the starting point and the b is the multiplier. So while trying to find the equation for the graph in part D of problem 866, shown again at right, Errol stated, I think a must equal 7 because the y-intercept is at 0, 7. Do you agree? I absolutely do, right? That's our starting point. But we still don't know what the b is. Errol noticed his teammate Sandy had an idea. I think that 56, right, we have the equation y equals a times b to the x. We've already determined that the a was 7, so I'll go in here and I'll change this a to 7. And we have this xy of 356, right? So I can go here and change the y to 56, and I can change the x to 3. I agree with that 100%, right? It's just like the one that we just did. And now I can divide by 7. 8 equals b to the third. I can grab the cube root of each side. And of course, the cube root of 8 is 2. 2 times 2 times 2 is 8. So my equation, use a and b to write the equation. So I would get 7 times 2 to the x. And if I plug 3 in, 2 times 2 times 2 is 8. 7 times 8 is 56. So I'm pretty happy with the equation. It does describe that graph. So we move on to 892. Mitchell was helping his friend work on his algebra homework. They were trying to write the equation of a line that passes through 5, 15, and 3, 7. Suddenly, Mitchell had an idea about finding linear equations. Look, he exclaimed, we know we can that the line can be written in the form y equals mx plus b, and we also know that the points 5, 15, and 3, 7 have to make the equation true. So we can substitute in these 2 points to create a system of equations. When we solve that, we'll know the values of m and b, and we'll have our equation. Makes sense. So what's he talking about? Use this method to write the equation of the line 5, 15. Well, again, we're using y equals mx plus b. So we know that 15 equals m times 5 plus b, as well as we know that 7 equals m times 3 plus b. A couple different ways that we could do this. I guess we'll just say, I'll just subtract 5m from each side. All right, so I get 15 minus 5m equals b. I'll substitute that in over here, so I get 7 equals 3m plus 15 minus 5m. So I'm going to get 7 equals 3m plus 15 minus 5m. I'll subtract 15, so I get negative 8. And I'll combine, I get negative 2m. So m is going to equal 4. And then I could just substitute it into either one of these equations and I should get the same thing. When I substitute it in here, I get 20 plus b. I subtract, I get b equals negative 5. And when I substitute it in here, I should get the same thing. 15 minus 20 equals negative 5. So I get the same equation either way. Oh, I'm sorry, I want to substitute it in here and see if I get the same thing. So 12 plus negative 5 does equal 7. So there we go. There's our m and our b. So it's y equals mx plus b. That's going to be our equation. I plug in 5, I get 20 minus 5 is 15. I plug in 3, I get 12 minus 5 is 7. So it did work. So I hope that makes sense. I went through that fairly quickly. And rather than go through it twice, maybe just rewind the video and reach out if you have questions. But will Mitchell's method work to write the equation of a line through any 2 points? Well, probably. So let's go ahead and let's see what happens when we get... Actually, I think it would be faster just to do this. Get a fresh sheet here and go down to the bottom, and we'll do it here. So what do I get when I use points 2, 3, and 5, negative 6? Again, this is all based off of y equals mx plus b. So on this one, I'm going to get 3 equals, I'll just call it 2m. I'm going to switch the order there. I'm plugging in 2 for x, so 2m plus b. And on this one, I'm going to get negative 6. Actually, I'll set these up. I think these might cancel out a little bit better. Equals 5m plus b. Let's see. Let's go for some elimination. What if I multiply this one by negative 1? And I'll just leave this one the same. So I'm going to get negative 3 equals negative 2m minus b. Here I'm going to get negative 6 equals 5m plus b. Good old-fashioned elimination. I love it. I get 3m, so m is going to equal negative 3. And now that I have that m is negative 3, I'll substitute it into this equation. I get negative 6, so I get 3 equals 2 times negative 3 is negative 6 plus b. So I add that, I get 9 equals b. And then I'll just confirm that that works here. Negative 15 plus 9 is negative 6. So I get the equation y equals negative 3x plus 9. So that did work. Feel pretty good about that. All right, so I will open up the next one here and finish off this lesson. So I think we did these ones. So that brings me down to 894. Mitchell thought that this method from 892 could be used to write equations of exponential functions. Mitchell wondered if he could write the equation of an exponential function that passed through points 2, 144 and 6, 729. But now we're going to write a curve. So now we're going to use the equation y equals a times b to the x. It says, what is the general form for exponential function that has an asymptote at y equals 0? Well, this is it. Use the 2 points that you wrote to create a system of equations. So I'm going to say, again, my y is 144 equals a times b to the 2. And on this one, I'm going to get 729 is going to be equal to a times b to the 6. It says, what are the values of a and b that make the system of equations true? Be sure to clearly show your strategy. So, and then we're going to write the equation. So I'm going to give myself a little bit of space here and get to work. I don't know how much you're going to love this, but let's go ahead and see what happens anyway. So we have 144 equals a times b squared, and we have 729 equals a times b to the 6. Well, I'm going to go ahead and I'm going to get the a by itself in both equations. So 144 over b squared equals a. Here, I'll divide by b to the 6. It's just going to be so much easier to get the a by itself than it will be the b by itself. I hope you guys all see that. Now, I know that a equals a, so 144 over b squared has got to be equal to 729 over b to the 6th. We'll cross multiply here. I'll get 729b squared equals 144b to the 6th. I'll divide both sides by b squared, so I can get them to one side. So 729 equals 144 times b to the 4th. I'll divide both sides by 144. So I'm going to get 729 divided by 144 equals 5.0625 is going to equal b to the 4th. So I need the 4th root. So I'll say 4 math 5. So I'm going to get the 4th root of 5.0625. And b is going to equal 1.5. Now at that point, I need to get my a. So I guess I'll go back over to one of these. It doesn't really matter which one. I'll pick this one. And I'll say 144 equals a times 1.5 squared. I'll use a calculator on this. So 1.5 squared equals 2.25. So 144 equals 2.25a. And now I'll divide 144 by 2.25. And I will get a equals 64. So it looks like I get the equation y equals 64 times 1.5 to the x. And that's going to be important. I'm going to want to remember that equation. As a matter of fact, I'm going to write it here so that I can sort of clear out the rest of this stuff. So let's clear it. I think I got my work cut out for me clearing this out. But let's try it anyway just to see sort of what happens here. So I have this equation, and I just want to grab a calculator and verify that this is actually even true and that this even works. So I'm going to go here, and I'm going to say, all right, well, I should be able to plug in these values of 2 and of 6 and get those values. So 1.5 to the 2nd power times 64 should equal 144, and it does. And then if I go 1.5 to the 6th power, and then multiply that by 64, it should equal 729, and it does. So I feel really good with this equation right here, but I want to show you something real quickly. You can use this method, but again, I like the method that we've already discussed a lot better. So it's up to you what you want to use. I personally don't love this method. I really only do it because the book says you should do it and show the kids how to do it. So I don't know my 0 term. I don't know my 1st term. I know my 2nd term is 144. I don't know my 3rd term. I don't know my 4th. I don't know my 5th, but I know my 6th is 729. I have 1, 2, 3, 4 b's. 144 times b to the 4th equals 729. I'll divide by 144. B to the 4th is going to equal, so, and we've already done this math, right? I mean, we've literally already done this math. 729 divided by 144 is 5.065. Then if I take the 4th root of both of these, I get 1.5. So we know our multiplier is 1.5. And now I can grab a calculator and just make sure I have that right. So I'm going to say 144 times 1.5. Uh-oh. So there we go. 144 times 1.5 equals 216. And then I'll just keep multiplying by 1.5 and I'll fill them in as I go. So 216, 324. Uh-oh. Criminy. All right, so 144, I screwed this all up. 144 times 1.5, 216 times 1.5, 324 times 1.5, 486, and then that was 216 right here, 324 right here, 486 right here. So if I multiply by 1.5 one more time, I should get 729, and I do, which means if I divide by 1.5, once and twice, I should get 64, which I do. So it's totally up to you which method you want to use. You get the same equation either way. I think what I'll do at this point is I will reopen this and go down here, and it's asking me to do these two equations. And I think what makes sense is, what if I do one the book way and then I do one my way, and we'll kind of go from there. So on the first one, it is asking us to say -2 equals a times b to the -1, and -162 equals a times b to the positive third, right? I'll divide by b to the -1. So I get -2 over b to the -1 is going to equal a, right? So I'll just leave myself a little bit of room here for saving time. I'm going to get -162 over b to the third also equals a. Well, if they equal a, they equal each other. So I'll do this. I'll cross multiply. I'm going to get -2 b to the third is going to equal -162 b to the -1. At this, I can divide by b to the -1. And I will create a little bit of room over here. I'll get -2. I hope we know that this bumps up to the top, so it'll be -2 b to the fourth, right? That's 3 positives. This -1 on bottom pops up as a +1 on top, so 3 plus 1 is 4. Equals -162. I'll divide by -2. I will get b to the fourth equals 81. So b, I'll take the fourth root of each, but it happens to be 3. 3, 9, 27, 81. That was pretty easy, right? I will go back over here. I will plug in a 3, so I get -2 equals a times 3 to the -1, which is -2 equals a over 3. So I'll multiply both sides by 3. And I will get -6 equals a. So my equation is -6 times 3 to the x. If I plug in -1, I'm going to get -6 over 3, which is -2, which is correct. If I plug in 3, I get 3, 9, 27. 27 times -6 hopefully equals -162. So times -6 equals -162. So I feel really good with this equation. Y equals -6 over 3 to the x. However, it's not my favorite method, so I will do the other one for this one right here. And I knew that was going to happen. All right, so let's go with the pencil. Give myself some more room here. And I'll say, all right, I know -2 is 28. I don't know what -1 is. I don't know what 0 is. I don't know what 1 is, but I know that 2 is 1.75. I have 1 B's, 2 B's, 3 B's, 4 B's, right? 1, 2, 3, 4. So 28 b to the fourth equals 1.75. I'll divide by 28. B to the fourth equals 1.75 divided by 28. Sorry, this video is getting long. 0.625. Obviously, I need the fourth root here, so I'll take the fourth root of b to the fourth. I'll take the fourth root of 0.625, and I will get the fourth root. Man, it's like not registering there. I keep hitting it, but it's not, I guess. Oh, I don't know. Let me close this and reopen it and see if I have any better luck here. So I'll get the fourth root of 0.625. So I get b equals 0.889. Great. All right, so let's see what happens. I just multiply this by 28. I get 24 point something here. I can't help but feel like I screwed something up. Was it 0.0625? I don't know. Times 0.889. This would be 22. Yeah, there's definitely something wrong here. So where am I off here? 1.75. So I want the 1.75 divided by 28. Oh, 0.0625. Okay, I'm sorry. So I want the fourth root of 0.0625. And I'm going to get 0.5. Oh, this all makes way more sense. Okay, so this would be 0.5. So 28 and half is 14, and half is 7, and half is 3 and a half, and half is 1.75. So I apologize for that mess up there, but you can see that the equation, my zero term, so that's my a, times 0.5 or 1/2 to the x works. So either method you prefer works fine. I prefer the second method, even though I screwed up the second method, ironically. Thanks.